Hey, my name is Erdin. We're Team 24, mouse microscopic observation utility for surgical exploration. And our project focuses on the in vivo two-photon microscopy imaging technique, which is used in imaging the brain while the mouse is awake. And it's specifically, for our cases, it's specifically used in cases of on the wheel setup. So the importance of this technique is that it's heavily reliant on the proper alignment of the mouse's of the cranial window. So I'll show you guys what the cranial window is. So basically this is the window that will be installed onto the mouse's skull, and this basically the microscope will shoot lasers through this little window to get to image it. Now in addition to that, we have another thing which is called a head bar, and this is a head fixation device that will be used on the mouse when it's running, when it's getting imaged on the wheel setup. So the problem with the current iterations of these is that right now to install this head fixation device, the head bar, the surgeon has to eyeball the installation of this head bar. And that's not good because that will distort the image, and which is not good for us. The other thing is that right now when it's getting imaged, the alignment between the microscope objective as well as the mouse, if they're not properly aligned, it's also going to distort the image. So that's where we come in. So our project will involve two parts. So we're trying to fix the issue by implementing two things, which is developing a surgical apparatus as we have over here, and this will help the surgeon. And the next thing is we're trying to develop a IMU-powered PCB that will be integrated into the setup to image better. And Annika will talk more about the apparatus.
Hi, I'm Annika, and I'm going to tell you a little bit more about this alignment apparatus that we created. So again, we need to attach this head bar to the mouse so that it's fixed during the imaging procedure. And you can see here, in surgery, the way they currently do it is by applying dental glue and balancing the head bar on it, which is not really an effective or very accurate way of attaching the head bar to the mouse. So what we designed was this head bar alignment apparatus, and that's going to hold the head bar in place during surgery. And you can see here, the apparatus can slide in and out on these rails here that just attach like that. To be removed before and after surgery, and then also have 3-axis micromanipulators here, so the surgeon can put the head bar exactly where they want it. So this will allow the glue to dry exactly where they want to place the head bar, and afterwards it can be the magnets can be mechanically removed from the head bar like that, like so. And so the removal of that apparatus won't interfere with the placement of the head bar. So that's how we're helping the surgical component of this imaging procedure, and then Brandon's going to tell you about how we helped the alignment part of the imaging procedure.
Hi, I'm Brandon, and I'm going to be going over the electrical component for our project. So here we designed some PCBs that will be used for measuring the angle of the optical window on the mouse's skull, and we're going to compare that angle to the angle of the microscope objective so that we can get perfect alignment. The first iteration we have here, this is a rigid PCB, and in the middle you can see a little black chip. This is called an IMU, or an inertial measurement unit, and this basically measures the angle of the circuit board when it's connected to a controller such as an Arduino. This PCB was designed just to test if the IMU that we chose actually works, and we confirmed that through running it with Arduino, and we moved on to our second iteration here. This is a flex PCB. And we decided to go with this because it minimizes the size given how small the microscope environment is, and it also acts as a cable itself, which reduces the number of parts we need. The problem with this one, however, is that the readings were very inconsistent, and so we decided to move back to a rigid PCB, except on a much smaller scale here, and we used a ribbon cable instead of the flex PCB for connecting over long distances. And this gives us the advantage of having a very thin and long wire. And so we will incorporate this into our setup by using a 3D printed insert that will connect to the PCB and lay inside the optical window, and that will give us a measurement of the angle of the optical window. And both of these devices combined, we can hope to redefine the procedure for in vivo imaging of head-fixed mice and improve the imaging quality using 2-photon microscopy. Thank you.